Welcome all, and I am giving the short presentation for my PhD defense. And as I'm working on the topic hybrid flow control method for supersonic jet noise mitigation, it is well clear that the off-design operating military jets likely to create the exhaust plume with the complex shock cell structures, and it generally irradiate three basic noises. The downstream direction, low frequency mixing noise propagates, and in the sideline direction 90-degree, the shock associated noise propagates, and upstream direction the screech tone propagates, which is dominated by the acoustic feedback. And suppressing these noise is likely to reduce the intensity of noise radiation. So here I am proposing a combined flow control method which couples the deflected seal concept with the serrated edge concept, serrated edges called chevrons. So here I am introducing the hybrid flow control method by fusing the deflecting seals with the serrated edges. And here I am adopting the flow visualization method, far field acoustic measurements, and statistical method to analyze the proposed nozzle. And here the flow control from the flow visualization studies, I have used the Scaleron flow visualization method, and as you can see, the data given here is for three NPRs for a Mach number of 1.6, NPR of 2.75, NPR 3.25, NPR 4.25. As we can see, at the lowest NPR, a jet exhibits highly underexpanded condition, and the shock angle decreases as the NPR increases in the base angle. But moving on to the modified nozzles, the chevron and the deflected seal chevron is giving the highest perimeter jet at immediately at the nozzle exit, and it is the clear indication that highest perimeter likely to increase the interaction with the atmospheric air and better the interaction and more the shear layer development and reduced jet noise. And at front also we can see the induced vortices from the chevrons are appears as a white streaks. And finally, when I couple the chevrons with the deflected seals, the jet comes with the highest perimeter, and also in overall the shock cell length and shock angle reduction was observed. And moving on to the overall sound pressure level reduction at NPR 2.25 across the three different azimuths 30, 60 and 90, and deflected seal chevron is giving minus 1 dB reduction, and at the higher NPR 3.25 the deflected seal is also giving the 2.5 at 30-degree and 2.5 at 135-degree, which is close to 5 dB reduction. And likewise for the other Mach numbers also 1.4 and 1.8, the far field analysis was done, and this is the sound pressure level which is given between the baseline nozzle and deflected seal nozzle across the 3 NPRs 30, 60, 30, 90 and 135, and the jet noise details are given here, and the fundamental peak screech tone, and it is also coming out with the multiple harmonics due to the high strength screech tone. And subsequently the deflected seal nozzle is experiencing a lesser harmonics than that of the baseline nozzle, which eventually ended up in reduced overall sound pressure level. And also I have carried out the statistical analysis of autocorrelation and cross correlation method, and the skewness based crackle jet noise analysis also. So here we can see that the baseline nozzle is given, and if the skewness value crosses 0.3, it is experiencing the crackle. It is happening at highest NPR 6.25 for the Mach number 1.4 and 6.75 for the Mach number 1.8. But for the same in the same scenario for the deflect seal chevron nozzle, even at the highest NPRs, it is giving the skewness magnitude which is lower than the threshold of 0.3, and so which is confirming that the deflect seal chevron nozzle suppresses the jet noise, crackle jet noise, and the respective crackle at 6.75 of Mach number 1.8 can be seen here. The zoomed in view is also given here, and the crackle can be identified as a N wave, which means a sharp rise and gradual decline and again the sharp rise. So the key overall outcome here is from the flow visualization study, I observed the reduction in supersonic core jet dimension, which means reduced shock cell length, shock angle, and higher shear layer growth. And overall sound pressure level reduction of 0.5 to 2.5 dB maximum at Mach number 1.6 nozzle. Likewise, for Mach number 1.8, it is between 0.5 to 4.2, 1.8 it is up to 0.5 to 5.8. And also the proposed deflected seal chevron nozzle completely suppress the crackle jet noise. Thank you.